Research brought to you by DigiKey and Adafruit. Every single week, Lady Ada user power engineer and help you find the things you want on digikey.com. Lady Ada, what are you looking for this week?
Okay, so this week I'm working on a design using the SI4732, which is available at DigiKey. I'm not going to look for it because it's a part number that I know about, and so I don't need to. If you want other chips in that family, you can check them out. They're from Scilab Skyworks. And this is an AM/FM shortwave long-wave receiver chip that's controlled over I2C, and it has an AM and FM antenna. And you can use an external antenna, or for AM you can use like a ferrite. For shortwave or longwave, you can use like one of those telescoping antennas that changes the capacitance. But one thing is, you can't go to my other monitor, so I'm going to drag this over.
Yeah.
If you go to the app note, not the data sheet, because the data sheet actually has like none of the stuff in it, but the app note for the 47 series, and they show all the family. So it's actually not in here. You're like, where is this 732? It's missing. It's actually the same as the 735, which is weird. But I don't know how, like they took the 735 and they just like made a new, the next version was a 732. I don't come up with the numbers. And you can follow with their instructions on how to do, the wiring. They tell you how to configure it. But the real big challenge is how to set up the antennas, because you want to have it be able to do, like I said, AM or FM. This is the headphone amp, which again, I kind of updated because it was mono and I was like, I want stereo. Let me find the 4.7 micro Henry. Okay. So the thing that was the challenging was I wanted to configure for the shortwave antenna, and they have a way for you to do either AM or FM or shortwave, and I think also long wave, using the 2 pins. So AMI and FMI are the 2 input pins. And this is the whip antenna, which is like they're missing an H. And there's a switch, and you can switch between AM mode or FM mode. So if you're using AM mode, you switch the switch down, and then you are connecting this ferrite antenna, this maybe you've seen it, it's like coils around a little bar. And that's the AM antenna for AM radio reception. But if you want to use it in shortwave mode, you flip the mechanical switch up, and then you're connecting this 4.7 microhenry inductor to your adjustable antenna, and then you can use the antenna to help you, tune to get the best config. So the only thing that's wacky is that you need to it's not wacky, but you need to kind of pick the right inductor. And they're like, well, you want the Coilcraft, I always look, because it's especially for like FM component, radio components, check what component they're telling you to use, because like they pick the right one. And if it works for you, just use it, right? Or at least you'll get good specs. Like they will tell you like the 33 picofarad capacitor for part of the filter, that one needs to be C0G, which is a stability and frequency range. Like it tells you, like, don't use, to be honest, every 33 picofarad is probably going to be C0G. But if you get to larger components, like this one, they're telling you it's not that important. You can use an X7R, which is a much lower requirement. But then, for this other inductor, again, you need to use this part that they recommend, which I did. But let's look up this inductor, and you can see, if I go to DigiKey, because I'm like, well, I know they carry Coilcraft. Actually doesn't show up. Now it's a little bit like, the data sheet isn't like terribly old. I will notice inductors, this was made recently, 2025. But inductors, like, they often like get updated and like they get improved, and then the part number changes slightly. So what I did is I searched for Coilcraft for the series, and I found the fixed inductors. And then I was like, well, I know it's going to be the 4.7 microhenry, so like I'll select that. And there's only 2 options, which was kind of nice. It's like, okay, I'm going to look at these. So they don't have the GLB, but they do have the XGRC. Again, like it's probably they changed like the temperature or stability, or like they improved something slightly with it. This is a marketplace product, so it's not stocked directly from DigiKey. It's sold directly from Coilcraft, which is fine. And they say the really important thing is minimal DC resistance and a Q of 20 or greater at 25 megahertz. That's basically like the resonance of the inductor. They're like, look, this is an important thing. You got to make sure that it's 20 at 25 megahertz or above. Okay, cool. And the self-resonant frequency is very high, which is good. I guess they like make sure it doesn't resonate in the frequencies that we're using, for like the megahertz, whatever, 88 megahertz is like FM radio, right? So maybe they need to be like above that. And then the size, 1008, which is a kind of standard size. It's surface mount. And then this is, I've seen these they have this cap. It's ceramic and it's wire wound. So it's good for, in this case, 260 milliamps. So this is not a bad inductor, and it's available, right? They have 10,000 sold from Coilcraft, takes 10 minutes or 4 days, $10 extra. Nothing wrong with it, but I did want to see if I could find an alternative, ideally one that's actively stocked by DigiKey, but also one that's maybe a little less expensive. Like this is like $1. That's a lot for an inductor that's like one component that's passive on this receiver board. So let's look for active wire wound 4.7 microhenry inductors. The DC resistance might change and the Q might change, but let's start with that and surface mount and see if we can get another inductor that has that same Q. Now, here's the thing that's a little annoying about Q, is they don't always use the same test frequency. So like you could find one that's like close and then also it's not like alphabetic, which is a little annoying. So there's like 16 at 25 megahertz. We actually want to be larger. We need to be 20. It doesn't actually look like there's one that would have a higher number. That's kind of like the highest it goes, 20 at 25 megahertz. So I'm just going to select that. Again, like you could go through others and look at the data sheets and like see what the Q is. But, to be honest, I don't want to spend a ton of time on this and maybe I'll find something good enough. So another thing they say is, okay, so let's just take a look. Yeah, these all look about, right? They say, let's look at the notes again. They say minimal DC resistance, where the other one had 4 ohm resistance and a current rating of 260. These are all about the same. Let's look at normally stocking and let's exclude marketplace. So let's look at ones that are actually available. And we got a couple options. There's actually, this is the Murata. It looks like they have just slight variations of the same LQW model. Looks like they have different cores. There's also one from TE. This TE one is actually like nearly identical. It's ceramic, wire round, 260 milliamp, unshielded, 4 ohm max. It's like basically kind of a clone of that Coilcraft. So if you wanted like the closest similar one, this would be fine. This is 39 cents each, 20 cents in quantity. But to be honest, if you're looking at the Murata series, and they have one that's air and then one that's non-magnetic. I don't know how much the coil actually matters. It might not matter at all, but non-magnetic and ceramic are basically the same. All other specs are identical: test frequency, surface mount, size, etc., current capability. And so even though I don't know what's up with this air one, the price change here is only like 2 cents difference, 1.5 cents difference, but it is half the price of the TE one. So I'm going to go with this one, which they have in stock. It like looks similar. It's got that blue cap on the top. Same size, 1008, 4 ohm, 260 milliamp, 4.7 microhenry, unshielded wire wound with that Q of over 20 or more. So I'm going to pick this LQW2. So now I just saved like 70 cents on my bill of material, which means it's going to cost $2 less at the end. So it's more like looking at each item on your bill of material, even that inductor, you can save a lot of money and make a really good product within specs at a good price.
And that is Lady Ada's great search pick of the week.
Where in the world is that part I need?